Okay, yesterday we finished off at this spot. This is 4-5, day 3, same order. And I want to talk about how we deal with the arguments inside that tangent value. This is on page 16 in your notes. Okay, so it should be kind of happy. And keep in mind, this is the end of day 1, and we did day 2 already. And we are doing kind of a connection day 1, day 3 today. All right. What I need to recall, period-wise, when we're talking about the period of tangent specifically, that goes from negative pi over 2 to pi over 2, from asymptote to asymptote. Okay, so keep that in mind. That is what I'm concerned about, that principal branch of tangent. So when I'm looking at something like this here, if it ever draws, I'm very interested in finding where I start, excuse me, square root over 2 of 2x minus pi over 4 less than or equal to pi over 2. I'm going to solve that simultaneously like we did when we were working with sine, cosine, cosecant, and secant. Now remember, that's why we grouped those 4 together, because they were from 0 to 2 pi. Okay? Tangent and cotangent are different. First of all, their period is pi. Okay? Tangent is from negative pi over 2 to pi over 2, the first one. And as we define it later when we talk about inverses, you're going to see why as well. So I'm going to divide by 2. It's multiplying by half. So I got negative pi over 4 is less than or equal to x minus pi over 4 less than or equal to pi over 4. You okay with what I did? I just multiplied by a half all the way across. Okay. Now, this is going to allow me to have a start and an end of where my period is supposed to be, my first full cycle. Okay. This may have a horizontal compression, okay, and shift in the phase, and it does. So keep that in mind, bless you, as we're working with this. We're going to add pi over 4, okay, across, that's what they had in there. So now this is 0. This is pi over 2. So right now I know my period has been compressed, okay, by a factor of 1/2. All right. Pi over 2 is its length. And I should know that because right now I can read that A, absolute value, is 1. B, we actually read was 2. My period normally is pi over B, which is 2. You know, I'm working with my B is 2, so that's where my pi over 2 period happens. And I just found my start and finish because I had a phase shift in this. Okay, it moved it to the right pi over 4. So that kind of makes sense as I made that shrink and then moved it. Now, I numbered my stuff earlier, and for the same reasons I talked about yesterday, because it's going to look really cluttered, I put all my key values on there, and I'm going to write my key values in right now, but I didn't show it on my graph on this one because it would have been really cluttered for notes. Okay, but maybe perhaps after I get my key values, I will put the ones that are missing in green. My key values, 0. Oh, by the way, pi over 8, right? So I got pi over 2. I got key values that would be pi over 8 because remember, pi over 2 divided by 4. Okay, same as multiplying by a 4th. Pi over 8. And if I was like 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. You okay with that? Okay, now keep in mind, I'm just going to do it on the first one because the rest is going to look all muddled. This is pi over 8. This is pi over 4. This is 3 pi over 4. And that's pi over 2. You see why I didn't put it in on all of them? I suppose I could have stretched it out a little bit, but I didn't want to. Okay, so that's where it is. Now, keep in mind, I'm working with tangent. Tangent, the start, remember, I had negative pi over 2 to pi over 2. Asymptotes are the bookends of my function as I'm working with it. And I purposely made sure that that would be the case when I shifted it. So now I have an asymptote at 0 and one at pi over 2. Bless you. And I got another one at, remember, the same period away, pi. And I got another one at 3 pi over 2. I also got them going back here as well. In this function, I don't have any vertical moves. There's no vertical translations up or down. Okay, so I'm pretty happy with that. So I'm just going to kind of put in, right in here, my axis. Just to remind myself I'm not going anywhere. It's not an asymptote. It's just I'm not going to go anywhere. That's my axis of symmetry. Okay. Now, I suppose I shouldn't say it's symmetry. That's my axis where I'm going to put everything on. Now, I'm doing tangent. And remember, as we go through tangent, the pi over 4, the negative pi over 4 is negative. Okay, it's negative 1. Positive pi over 4 is positive 1. I don't flip this, so I'm going to start out. My first quarter is going to be negative 1. Second quarter, positive 1. I'm just thinking pi over 8 goes in. I got negative pi over 8. That's 2 pi over, that's negative pi over 4. That's going to be negative. Yeah, okay, so I'm all happy with that. So we're doing this. And keep in mind that's 0. This is 0. That's 0. This is 0. This is 0. This is 0. Negative, positive. Negative, positive. Okay, negative, positive. Negative, positive. Negative, positive. And the whole function just kind of gets laid out. Shoot.
How do you know which way the curve goes?
I just guess. No, how do I know? The question out there, the question out there was, how do I know where the curve goes? And I jokingly said I just guess. So let's talk about it. When we're talking about the general function for tangent, okay, we have that pi over 2, and then I have pi over 4. Then those are negative, right? Then I have 0, and I have positive pi over 4, and I have pi over 2, and that's another asymptote. So generally, when I'm looking at tangent, and I'm thinking about it, tangent of 0, okay? I'm thinking unit circle here, okay? And I know I'm going to be writing right over the top of this stuff, but that's okay. If I'm talking about the tangent of 0, I'm looking at 1, 0. Sine is 0, and tangent sine over cosine, so at 0, 1. So that's where my 0 is, right there at 0. Now, if I talk about negative pi over 4, I'm talking about down here, and positive pi over 4 is up there. Okay, positive pi over 4, tangent would have to be positive 1, because it's the square root of 2 over 2 divided by the square root of 2 over 2. They're the same value. So here, my tangent of pi over 4 would be 1, so up here, I'm at 1. Okay, negative pi over 4, my tangent sign switches, so it's negative 1. Now, knowing that every time I work with my tangent and I have a compression or a stretch, those 5 critical points I find. First one is my asymptote. Second one is my value of 1. Even if I put it in, it should come out 1. So my second one, my value of 1. Whether positive or negative, we got pi over 8 here, right? Put it in the function. X minus pi over 4. X is pi over 8. That gives me a negative pi over 8 inside times 2. Negative pi over 4. Well, what's the negative pi over 4? It's negative 1 as a tangent. And that's how I know I was able to go at negative 1 at that point for y. Okay, does that make sense? Because we're doing this with the pattern, those 5 critical points help me do that so much faster. I just click them off because I know the first one's asymptote.
So then if it was
My negative 1, my 0. My positive 1, my asymptote. It would just flip the other way, and it'd be a positive 1 my first, and then I'd also need to look at my amplitude, because if it's any number other than 1, I have to multiply my 1 value times my amplitude, whether it be a half, a quarter, or 40, whatever it's the stretch or compression it would be. Does that make sense? Okay, any other questions on the floor for that? Okay, so now I get this going here, and that generally is my function. Oops, forgot this one. I'm looking at. Okay, make sure we're approaching our asymptotes on the side as we're going down. okay? But that's our function. Now, I could do it again. You guys are asking some great questions. Cotangent and tangent are related to each other by a reflection and a phase shift. Okay, I forgot to add that phase shift in yesterday when I think mentally about what I say in notes, and I just shake my head some days. But I look at it as you got to think about the reflections and a shift. Okay, and that shift is pi over 2. Okay, as we talk about it. So what I want you to do is give your cotangent skills a try. This one's A's 2. Give it a try. Because the worst case scenario, you're wrong. Best case scenario, we start fixing the places we're making errors. And that's why you're here. That's what we're doing. Okay, so I want to make sure it's clear. I want to be able to talk to you guys about it as we're going. So let's check this out. Give this one a try. Get on. We're doing these. Okay, so we've got that one done. You're doing this one. On your own, cold. Yeah.
So sometimes I get confused. Do we take this out?
I would take that to find, and because cotangent goes from 0 to pi, okay? Cotangent's from 0 to pi. I would put that between 0 and pi and solve for x to find my start and finish. Well, your b, you factor that out to find b. Because whatever's with x, you factor that out to find your b. Yeah.
Why did this start as pi over 2 instead of 0?
That's why. Okay, so cotangent. First thing, let's find b. Are you okay with 3? B's 3. Okay, so A, let me get a different color because I've got blue all over on the other stuff. So A is absolute value, my amplitude is 2. My B, absolute value again is 3. Remember, tangent and cotangent, because signs involved with it are odd functions. So if it was negative, it would come out to be part of the A function, the A value, okay, and it'd be a flip. But it's not, so it's good. My period, remember, for cotangent is pi. So it's pi divided by 3, okay? That's the length of my period is pi over 3, okay? So I should have 3 waves in a pi if I talk about frequency, the reciprocal of period. We are looking at, remember, cotangent starts at 0, it's an asymptote, and goes to pi, the other asymptote, the bookends of the function, okay? So we go 0 to pi. And so with that said, I'm starting at 0, less than or equal to 3x minus pi over 2, okay, and is less than or equal to pi. I'm going to add pi over 2 to everything. Are you okay with that? So in adding pi over 2 to everything, so I can get x by itself, I get pi over 2 is less than or equal to 3x, which is less than or equal to 3 pi over 2. You okay that pi is 2 pi over 2? Yes, dear. I wanted to show both with this because I can just solve this and you'll see the phase shift. I could have taken that 3 out and it would have been pi over 6. Okay, does that make sense? And I would have known that phase shift would be to the right pi over 6. But now when I'm dividing by 3 right now, you're going to see that it's going to be pi over 6. Okay, so I'm going to divide by 3 and I have pi over 6 less than or equal to x, which is less than or equal to pi over 2. Because I'm dividing by 3 and I got 3 pi over 2. Okay, now let's talk about the fact that I got pi over 3, which is the same as 2 pi over 6. Are you okay with that? Okay, so, and the reason why I'm adding that is I want to make sure you recognize from pi over 6, I add 2 pi over 6, I get 3 pi over 6. 3 pi over 6 is the same as pi over 2. So I have my start and my end of my first part of the function. And then I just repeat it every pi over 3 as I go. Does that make sense, what I've done? The thing that's making this funky is the fractions, and that's the part of that setup that's hard. After I get the setup, after I get my 5 key points and I put them down on my graph, that's when it becomes easier. Okay, because I start looking for my spots where it's 1. My second values are 1. So pi over 3 divided by 4. Ain't that pi over 12? Wow, pi over 12. So I've got myself pi over 3 divided by 4 is pi over 12. Okay, I'm going to talk about pi over 3 in 12ths. Okay, so we can get this going. Are there any questions about what I'm doing so far? Is it feeling comfy? This one's harder because of the fractions, I'm going to be honest. Okay, so remember, I got a starting spot, pi over 6. So pi over 6, my first, or that is the same as 2 pi over 12. My end is the same as 6 pi over 12. Okay, does that make sense? I got my start and end in 12ths, so I know when I'm adding, I haven't screwed up. Okay, so pi over 12 at a time. 3 pi over 12, 4 pi over 12, 5 pi over 12. You okay with that? I'm okay with that. I'm just wondering what I did with my units on the bottom of my graph, what I was thinking. Yeah, I got it in 12ths. I just kind of broke it up funky. So I'm starting at 6. Pi over 6. This is the same as pi over 6. And my evens will, I mean, this is the same as pi over 4. Okay, but I don't want to make it too crazy. I'm going to put it in 6, and then I'll go 6 and a half so I don't have to flip back and forth. This is, well, not going to be pi over 6. This can be 3 pi over 12, which is almost 4 pi over 6, so we're going to worry about it later. So I'm going to start at pi over 6. This is in 12ths. That's a 12th. That's 3 pi over 12. Okay, so I've got my pi over 6, and I've got it even. I don't know if I slid that over. Good. My asymptotes, pi over 6. My other one, 6 pi over 6, which is the same as pi over 2. Pi over 2 later. I got a 5 pi over 6, pi over 2 is 3 pi over 6, 4, yeah, 5 pi over 6. Okay, you okay with what I did with those? Yes or no? They're pi over 3 apart. We okay? Any questions about what I'm doing? Okay, so once we get my asymptotes in, and I break them down going backwards too. Okay, I got my four spots, and I'm going to try to get my zeros in there. But I got my first one, my second one, my third one. 1, 2, 1, 2, 3, 4. That's 2 pi over 12, 3 pi over 12. It's cotangent. It would normally be positive 1, but because of the 2, it's positive 2 up here. My 0, negative 2. Okay, once I'm happy with those, I'll double check that. It's the same pattern for every other situation I have between my bookends, my asymptotes. So I've got it here, I got a 0, and I got it here. I've got it a 0 here, I got it here, and I got it here. I got a 0 here, got it there, got it here. Because of the breakdown, when we do this, the pattern for this graphing, because it is cyclical, it happens all the time, every pi over 3, I can get away with this. You okay with that? But remember, pi over 3 is the same as 2 pi over 6. Okay? And it looks a little bit different compared to the other one that we did. I suppose I should put arrowheads on these. Ooh, that's much easier to do. Difficulty created because of funky fractions. F squared. Okay? Any follow-up questions? Okay, let's look. They're skipping over stuff. If we can get there. We got to skip over day 2. I think we're on page day 3. Wow, I just blew right by that. We're talking about solving. And when we're doing the solving stuff, we're really using the ideas. There's a couple ways of looking at it. They're asking us to solve for x. You can use the inverse function, and really that's what we're thinking about, because you take a ratio, you put it into the inverse, you find an angle value. But we're using reference triangles in these. So in example 5, solving a trig equation algebraically. Okay, find the value of x between pi and 3 pi over 2. Are you okay that that's where 3 pi over 2 is and that's where pi is? And keep in mind the other main keys. Okay, they told us that secant x is equal to -2. Okay, now secant is your x value over your r, your radius. But for those folks that don't remember that, I wanted you to realize the secant is the same as 1 over cosine. And that the reciprocal of that is just cosine x. So now I'm looking for a value between pi and 3 pi over 2. This is the area. Okay, they told me the area, the range I'm looking for, that has a radius of -2. Well, really won't be -2. The radius is always positive. The radius is 2. My x value, because cosine, is 1. Or, if you could just recall the unit circle, what values have x as -1/2 and the radius is 1 if I talk about unit circle? I have some concerned faces on that. So I'm going to go use the unit circle. And I'm saying that this is -1/2, right? I'll just do it this way. This will be fun. You guys will see it. This is 1, this is 2. For those folks that aren't remembering the unit circle, let's talk reference triangle for a second. I've got 1 squared plus whatever that is, we'll call that y squared, equal r squared, 2 squared. Well, that's 1. Y squared must therefore be 3. Y must be the square root of 3. Hey, that's like a 30, 60, 90 triangle, right? And the 30, 60, 90s, that's pi over 3s. So I've got pi over 3, that's 1. 2 pi over 3, 3 pi over 3. This is 4 pi over 3. Okay, 30, 60, 90 wise. So if I was going to talk about unit circle measurements, and, excuse me, 1, unit circle measurement wise. So I have some people that look at this and they'll come up with, hey, you know something? X is equal to 4 pi over 3 when I'm looking that over. You okay with what I'm doing with my reference triangle? You okay with the recall of the unit circle? Okay, I know it's a little sketchy right now because I promised that I would use it, and now since I made that emphasis, I use it like 2 plus 2. And I will use it like 2 plus 2 for the next 6 weeks. Okay? I promise. It's a promise. It's a guarantee. Unit circle is your lifeline. And if you don't believe me, you should go to your talk to your calc folks in AB. They use the unit circle like every day. Okay? So now, that's my answer. I'm done. Next, let's look at a U-try. Cosecant x equals 2. By the way, cosecant, 1 over sine, right? So start it. Start working it. At least set up your reference triangle, okay? Get that. And then make it a unit circle triangle by dividing by the value of the radius. Get that, all right? between pi over 2 and pi. I already know that's where it's going to be. And I already know that I'm going to talk about it as a half. Because this is 1, this is going to be a half. And if you need to, remember, over 1, hypotenuse. You can use 0.5 if you like. Square root of 3 over 2, but it's negative, right? It would have to be in that area. So are we okay with where we're going with the unit circle stuff? Now, you didn't have to. I'm going to show you the reference triangle version. That'll be fine. But I am using unit circles, so that's what they're looking for. They're looking at radians. And this is 5 pi over 6. You okay with that? So I've got x is equal to 5 pi over 6. So that's 6 pi over 6, and I go back 1. And that's between pi over 2 and pi. Bless you. Questions? Now, if I didn't see it the way I just saw it, and I just did it reference triangle wise, still doing this, still looking at this, still talking, well, this is 2. I got this as 1. I got to find x. I would find x, okay, as the square root of 3. Okay? Then I'm talking about that's my angle they want. I got a reference angle here. That's still 5 pi over 6, but I'd still have to divide by 2 to find it. I have to have that knowledge of the unit circle to get this done. Okay? So I could divide by everything by the same to make my hypotenuse 1, and I can get that done. So whichever way I want to look at it, if I want to look at it that, and I can do it in the air the way I just did, I still got to divide by my radius to make it a unit circle, and this is still, x is 5 pi over 6. It won't change my answer. Okay? What do you know about tangent and cotangent? They're reciprocals of each other, right? If cotangent 1, what's tangent? That's 1 as well. So now the only thing that I'm asking is, first, which value on the unit circles, I should say values, have the same cosine and sine value? Do you guys know what they are? Pi over 4s, 3 pi over 4, 5 pi over 4, 7 pi over 4. Or the negatives, negative pi over 4. Okay? Or so you got to look at that as you're looking at it, negative 3 pi over 4. So they're saying this. If you're not used to seeing that, that's fine, but cotangent, x is the same as, remember, tangent is sine over cosine. Cotangent is cosine x over sine x. And they are the same. Square root of 2 over 2, square root of 2 over 2. That's the only time that they're the same. They're positive, so they have to have the same sign. So there's only 2 places that these can be. Okay? They're either both in the first quadrant, or they're both in the third quadrant, because it's positive. Here, they're saying that it's got to be between negative pi over 2, and negative pi, third quadrant. They're saying it's in there, okay, when I'm looking this over. Now, keep in mind, here, I've got the square root of 2 over 2, and the square root of 2 over 2, and they're both negative. And that is, remember, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4 is my x value. Completely and totally found because of the unit circle and knowing what's going on with my triangle. I guarantee unit circle is going to be turning its ugly head all the time. I would keep going back and redoing it. Okay, same values all the time. Last one. Solve graphically. it says here. Take out your calculator, make sure it's in radians. Make sure it's in radians. Y1 should be x squared. Y2 should be, remember, cosecant. If you have a Inspire calculator, you have the cosecant already there. But if you have a 84, remember cosecant is 1 over sine, right? So we have 1 over sine x. Remember, your calculator must be in radian as we look at this. And they give you a window. Use that window. I want to make sure you know what's happening with this. And what you're going to do, you're going to have 2 graphs on your calculator, and you're looking for the intersection point. This bad boy right there. Okay, so get that set up on your calculator, and I'll see if I can get caught up to you. Now, the reason I'm doing it this way is they ask us to solve it graphically. So I'm just doing what they told me to do. I just want to make sure we bring back the stuff that we already know how to do, and we don't have to do anything new. You know, you'd think somebody would actually preloaded this. How big is my window here? Ooh, that's okay. They tell me to use negative 6.5. So I'm going to use negative 6.5 as one x, and 6.5 is my other one. And then my min for my y is negative 3.3. And graph. Okay, so I'm graphing, and this is my point. This is where I've got my intersection. So I go up to second calc, and look for my intersection point. That's all I'm going to do. But I have to make sure my calculator's in radians, otherwise my trig function will it won't graph right. All right, so I'm looking at second calc. Okay, I'm going down to 5. I suppose just say 5 intersect. And that's my first one. I'm going to lean on this side. Answer, happy as a lark. And I get 1.07. You okay with this? I'm starting to question how I got that, but that's my intersection I've got going. Do you guys get anything different? We're okay? Oh, yeah, so you got to go to mode, you got to go to radian. And then should be off the graph right off that. Okay. Is it good? All right. Any other questions? All right. Now, here's the thing on this last part of today's notes. It's just a cheat sheet for you to remind yourself about stuff. Okay, about what tangent is, what cotangent is. And these are real general, straight up. But keep in mind, I would make sure, if I were a student going through tangent, negative pi over 2 less than or equal to x less than or equal to pi over 2. Cotangent, okay? I don't know why they don't have in there. I wish it were. 0 less than or equal to x less than or equal to pi. Cosecant, secant, both of them. 0 less than or equal to x, which is less than or equal to 2 pi. And that's because sine and cosine are 0 to 2 pi. Okay, I would make sure I have those ranges in my head when I do my reading of my notes to make sure that when I'm setting those up for my test, I want those ranges to help me with my phase shift. okay? And then it has the general rundown of what's going on with the domains and everything else. Are there any follow-up questions? Yeah, I can. I'm sorry. I kind of rushed that through. So I would make sure that those are in, because when I set up a phase shift, those are the values I'm working with for tangent, cotangent, and cosecant and secant. Also sine and cosine. Now, one of the things that have been asked is we have a couple questions. For those folks at home, I'm going to turn it off so you don't feel like it's going to take forever. This is a long enough video as it is. But that's the end of it all. And if you've got your assignments, those are the things that have been going on the last few days. And I flip-flopped my days, I guess. I guess this was still day one. I just made it day two, one day. So we won't worry about that. I'm going to put it that way. That's the way I look at it. Okay,